In this video, we're going to be taking a look at the Rebuild Surfaces command. Now, this is probably the single most important command in all of NURBS modeling, because you're going to be using this to clean up the detail of your NURBS surface. You'll be using it to add detail or remove detail without changing your surface very much. You'll be using it to clean up your parameterization. It has a lot of different functions. Now, I'm not going to get too bogged down in the workflow issues of rebuilding. That's something that you're going to see in the workflow videos included with the NURBS modeling section. What I'm intending to do with this video is just to show you all of the various settings of the Rebuild Surfaces command, show you what each of those settings are intended for, and then we'll just move right along. So, for starters, let me create a NURBS surface, like so. And we'll move this up into the air, kind of get it away from the grid. Now, if we go under Edit NURBS, Rebuild Surfaces, and fire up the options box, let's go ahead and reset all of our settings. You'll notice that by default, you have a lot of settings in this window. Don't panic. For one reason, the settings themselves are not really all that difficult. They're all very easy. Second of all, you're not really going to be using all of the settings in this window very often. In fact, there's just a few areas of settings that you'll be changing with any kind of frequency. For the most part, you'll leave a lot of these alone. Now, the first area we have is Rebuild Type. This allows us to control what kind of actions we're going to be performing on our surface. There are 8 different rebuild types. We have Uniform, Reduce, Match Knots, No Multiple Knots, Non-Rational, End Conditions, Trim Convert, and Bezier. Now you'll notice that these options down below are going to change as you click on each one, which is okay. A lot of these options are going to be identical to things that we'll talk about as we go through, and we'll discuss each one of these as we go along. We're going to start off with Uniform. Now, Uniform is probably the most important setting that we're going to use here. We'll be using this 99.99% of the time because, of course, Uniform gives us a nice, clean, even surface that's easy to read, easy to texture, easy to skin. It's just going to be the best setting all around for giving ourselves nice, sharp, clean, smooth surfaces. Well, sharp and smooth, I know that sounds a little different, but it's good. So we'll be using Uniform more than anything. Now, inside of Uniform, we have a lot of different settings that we can control. First off, we have Parameter Range. This is where you can change the parameterization of the surface. You can set this to 0 to 1. You can keep the existing parameterization, or you can set this to 0 to number of spans, which is my personal favorite because it allows you to have nice feedback on your surface of how many spans there are. And as long as you can count the spans in the viewport, you know the parameterization of the surface, as long as you stay consistent to that type. Down from here, you can control the direction in which you'd like to rebuild the surface. You may not necessarily want to rebuild in U and V together. You may only want to make changes to the surface in the U direction, or just in the V direction. Of course, you have the option of doing this in both directions. Down from here, you can choose various aspects of the surface to keep constant and not change during the rebuild procedure. You can keep the corners constant, meaning that your corner CVs will not change through the course of the rebuild. They will stay right where they are, which is very handy if you've already got a patch model set up and you don't want those corners to move accidentally, but you are interested in maybe moving around some of the CVs in the middle of the surface. You can choose to keep the existing CVs. Now, this is a setting that's very important, and we'll be using this a lot. Essentially, what this is going to do is allow you to clean up your detail, make your underlying isoparms all nice and uniform, while keeping your CVs in the same location so that as you're modeling, the CVs that you're moving around for sculpting and whatnot don't move around. They don't go to any different location. They stay right where you put them. We're going to be using this a lot as we model. You can also choose to keep the number of spans constant, so if you've got a number of spans that you like and you don't want to change, you can check that. Now, if you're not keeping your number of spans, you do have the option of setting the number of spans to an explicit value, so you can set the number of spans in U and in V to any number you want. Like we could set this to 3 by 4 is fine. Let's go ahead and click Apply, and boom, there we go. We have 3 spans here in U and 4 spans in V, like so. Now, you can also change the degree of the curvature of the surface in U and V. So if you need to change this to a linear surface in U or V, or to a 2-degree square surface, cubic, whatever you want, In all of our examples, all of our modeling, we're just going to be using cubic surfaces. They are a standard, so there's no real reason for us to change that. But later on down the road, when you're working on your own stuff, you may decide that you need to use that. So there you go. Underneath this, we have the ability to keep the original surface after we make the rebuild. So basically, we'll duplicate this and we'll rebuild the duplicate instead. The handy thing about this is this allows you to really kind of explore your settings and make changes to it. You'll actually get a rebuild node that you can operate. And if you are using the rebuild surface tool for the first time and you just want to kind of get a hang of all the settings and what they can do and what you can do with the command, then it's not a bad idea, just as an experiment, to switch on Keep Original. I'll plug in a number here. Let's just say 5 by 5. Let's click Apply. Notice we get a new copy of the surface. Over here we have a Rebuild Surface node. We can go into the Attribute Editor, access that node, and now we can change the rebuild type to any of the build types that are inside the Options window. We can change our spans in U, change our spans in V. We can set our degree of the surface in U or V to anything. Basically, all the options that we have access to in here, we now have access to, and we can see how they change the surface physically right here. So very, very handy. Good for learning. Probably not the kind of thing that we're going to really be using, ever on the model, just because we'd have to go back in and clean up those original surfaces and delete those out. And that's way too much like work for what we want to do. We just want to model. We don't want to get bogged down with deleting a bunch of stuff. So there's Keep Original. Now down from here we can control what kind of output geometry we want to have. Now because we are NURBS modeling, we're going to be leaving this set to NURBS. There's no reason to change it, but if you want to change it, like let's say you want to rebuild and have your output come out as polygons, of course you can do that, and you have all of the same tessellation options that you'll find under Modify, Convert NURBS to Polygons. So very cool there. You can also output to subdivision surfaces if you like. But, you know, if you're modeling with NURBS, really in general, you're going to be keeping this at NURBS. There's really not much of a reason to ever change that. Now, that is all of the that's all the settings inside the uniform setting. Again, one of the most common functions that we'll be doing throughout our modeling process is leaving this set to uniform and keeping our CVs so that we can clean up the underlying detail, the underlying spans, isoparms, while we leave our CVs intact. It's going to be very, very useful to do that. In fact, I can kind of show you that if you want. We could grab some CVs here and move these around, give these sort of a interesting position. In fact, let's grab just these two over here, and I'll pull them way up into the air. Then what I'm going to do is grab an isoparm, somewhere at a random selection here across. Let's go ahead and cut the surface. I'll delete this out. Now, you can see, one, that my surface is not uniform, not nicely cleaned up. Second, my parameterization is going to be a little bit off, 1.734 to 3, so we're dealing with a chord length surface. So I can rebuild this to uniform and keep CVs. I can hit Apply. Notice the spans clean themselves up, but when I go to Control Vertices, the CVs are exactly where I left them, which is going to be very, very handy as you work on NURBS models. So from here, we have the ability to reduce, the second rebuild type we have. Reduce. Now, before I use reduce, let me create a surface just for testing purposes. What I'm going to do is, first off, rebuild this surface to uniform. Let's switch off Keep CVs. We'll set this to a 5 by 5 surface. Let me undo this real quick. I want to make sure I'm not keeping original. There's really no reason for me to do that right now. And let's grab some Control Vertices. I'll pop this up into the air. And that'll work for now. So I just want some curvature is really all I'm looking for to make the surface maybe a tad more interesting. Now I'm going to rebuild this to just an atrocious amount of detail. Let's say something like 16 by 16. So I have tons of detail. We'll grab a few CVs and relocate them. Oh, by the way, if ever you run into this, you do a rebuild, you try to move some CVs and they won't move, it's because history has locked them. So all you need to do is come in, delete by type, history, and you're good to go. So I'll grab a few CVs and I'll pull these up as well, just in a couple of different areas like so. Now, let's say I look at this surface and say to myself, I have way too much detail. I really need to bring this down if at all possible. You can use the Reduce rebuild type, and its whole purpose is to use a threshold to get rid of excess detail. Now, that threshold is going to be in your tolerance. Now, you can use the global tolerance, which, of course, as you probably already know, is located under your preferences here inside settings. And we'll be using the positional tolerance. Or you can set your own tolerance at the local level just by checking local and giving this a number. Now, here's how this works. What Maya is going to do is take each span, or actually each knot of your surface, and it's going to try to remove it. If it can remove a knot without any of the other knots moving a greater distance than your tolerance, then that knot is gone. As soon as the surrounding knots move more than the distance, more than your tolerance, basically what that means is if it removes a knot and the surface changes too much, then it won't remove that knot. It'll decide that the knot is too important to be deleted. So what that amounts to in this case is we can switch on Keep Original just as an example. Let's go ahead and rebuild. We'll pull our new surface up, and you can already see how this has gotten rid of some of the detail. If I were to put these side by side, then you can definitely notice the difference in detail. But I can come back over to this guy that we rebuilt, come over to the Rebuilt Surface node, and change that tolerance. And the higher my tolerance goes, then the greater distance that knots are allowed to move as we take out detail. So you'll see the surface get greater and greater simplified. So more and more detail is pulled out the higher we go. And you can get some really crazy stuff if you go too high. But within reason, if you keep it kind of low, you can really make some nice adjustments to your detail, keeping your surface nice and clean so it doesn't get too bogged down. So that's the whole point of the reduce rebuild type. Again, just a way to get rid of excess detail from your surface, kind of optimize things a little bit. Down from here we have match knots. Now let me go ahead and delete this surface. Now, match knots is a very useful rebuild type, and it's there as sort of a way to help maintain a good workflow in NURBS models. You'll notice that when you attach a surface, when you use a surface to bi-rail another surface, it's going to help if the surfaces in question already have the same number of spans, if they have the same parameterization. These things are really going to help your modeling operations go more smoothly and give you a cleaner surface when you're done. So you have a couple of options you could use here. For example, let me go ahead and let's just pretend this is a new surface. I'm rebuilding it just for the sake of creating an example. So we'll do a 3x5 surface, and we'll just, let me undo that real quick. Let me go back to Edit NURBS, Rebuild Surfaces. It looks like I have Keep Original on, so let me switch that off. So we have one surface that is, in this case, 5x3. Now let's just assume that we have another surface that we'd like to attach. And before we attach, we'd like the number of spans on this surface to match what's on this surface. Now, to do this, we have a couple of options. We could come over to this surface. We could count up its number of spans, verify that in the attribute editor. We could go over to Edit NURBS, open up Rebuild Surfaces, select this surface. Now, if we look over here, notice it's 3x5. So we could grab this guy, rebuild to uniform. We could set this to 3x5 or even just 1x5 and rebuild. But we had to come in here and we had to research. We had to figure out how many spans there were. We had to plug in numbers based off what we found. There is a simpler way. If we want, we can simply select the surface that we'd like to rebuild, Shift-select the surface we'd like to match to, go over to Edit NURBS, Rebuild Surfaces, and choose Match Knots. And this is just going to take the amount of detail from the second surface and send it over to the first. It'll also take over parameter range. It'll basically match everything up as far as the integrity of the surface and send it over here. Now, when you activate Match Knots, you have two different rebuild methods that appear. You have Classic and you have Match. Classic is an older algorithm that I believe dates back to Maya 5 and later, and Match is a newer algorithm that will produce better and cleaner surfaces. So that's what we'll be using. This is here as kind of a legacy issue. So we'll switch over to Match. Click Rebuild, and there we go. So we've just taken the amount of detail and moved it from the second surface back over to the first. Now, I have had some students in the past, just when they're taking notes or in their head, they just assume that this also means that it will carry over any kind of modeling. So just to make sure there's no confusion, let me undo that. I'm going to grab some CVs here in the middle of this plane. We'll move these up in the air. So notice that some sort of sculpting has been done to this surface. Now, again, select the surface you want to rebuild, hold down Shift, select the surface you'd like to match up to. We'll go over to Edit NURBS, Rebuild Surfaces, And notice we have match, match. Let's go ahead and rebuild. Notice the modeling, the actual positioning of the CVs did not come over. It's just the amount of detail that comes over. It's very important that you keep that in mind. That is the primary function of the match rebuild type, just a way for your surfaces to match up so that now if I wanted to, I could grab these two surfaces, and if I attach them, you'll notice that they attach nice and smoothly because all of that detail lined up. So let's see, let's go ahead and get rid of that. Now, down from here, we have the no multiple knots rebuild type. Now, let me go ahead and create a multiple knot for this to make sense. Multiple knots, you know, they're kind of cool in that they allow you to create a corner in your surface. Like, for example, I can go under Edit NURBS, Insert Isoparms, and let's see, at selection set to a multiplicity of 3. That's all well and good, so we'll go ahead and insert like that. These do get a little bit problematic in that not all rendering engines support them, first of all. Second of all, it can be confusing to other modelers in your scene. Even if we can grab these CVs and pull them up. And you'll notice we get a corner, so we know that we're some kind of multiplicity there. But a modeler would actually have to go in and double-check your number of spans and verify how many knots are in there in that spot. These things can just kind of get in the way, and then in most cases you won't want to have multiple knots stacked on top of one another inside your surface. I mean, I guess in some very particular instances they can be useful, but let's just say we don't want them for this example. So we'll go over to Rebuild Surfaces, and we have no multiple knots. And inside of this, all you can change is just the parameter range. Oh, by the way, just one quick thing. When you're matching knots, remember, you can adjust your parameter range. You can still, of course, control the direction of the rebuild. You can choose to keep corners and CVs. So if anything you still see lit up, of course, you still have access to. So back to no multiple knots, where all we have access to now is changing the parameterization of our surface. So let me go ahead and just click Apply, and boom, all it did was just kill off the multiplicity of those isoparms, so that now we no longer have a corner. Everything is nice and clean. And it is, while it's been there, it's gone ahead and adjusted our parameterization as well to 0 to number of spans, which we can verify here. So very cool. That's really the whole reason that's there is just to get rid of any multiple knots that you may find on your surface. Now, the next rebuild type is not really something that I can demonstrate for you. All I can really do is tell you about it, and you'll have to do some more research or take my word for it, but really for the most part, this is not something that many, if any of you, are ever really going to have to worry about. That's the non-rational rebuild type. Now, NURBS, as you already know, stands for Non-Uniform Rational B-Splines. Rational, in this case, refers to the fact that you can take the CVs of a NURBS curve. Now, hang on a second. Before I go any further with this, realize that I'm talking about the mathematical definition of NURBS curves. I'm not talking about NURBS curves or surfaces as they exist inside of Maya. A by definition NURBS curve, you can take its CVs and you can add or remove weight from them. As you increase their weight, the curve will start pulling closer to a CV. As you remove weight, it'll move away from it. You may have already noticed that you can't, by default, do this inside of Maya. There's just no way to control that. The reason for this is that type of control over NURBS curves is for very high precision models. Say things you're manufacturing, like a car model that's got to go to an actual manufacturing plant based on very, very precise figures. Maya deals primarily with entertainment models, things for movies, things for games, where you don't need that level of precision. So because of that, the ability to change the weights of NURBS CVs has been cleverly taken away from you. And the reason for that is because a surface that has even spacing, even weighting on each CV, a non-rational surface in this case, is much easier to calculate. It's a lot faster. So to keep things nice and quick, and because you'll probably never need the power in the first place, you do not have the ability to adjust the weights. However, you can import models from other packages, of course. So if you have brought in a model from another package that allows you to adjust CV weighting, then you might find it a lot better to convert it over to a non-rational surface, meaning that you take all those CV weights and set them all back to 1, so that the surface will kind of update much more quickly inside of Maya. Maya has an easier time with it. That's really all that non-rational's for. Inside of this, you can also adjust your number of spans for that surface, and you can control the tolerance that is used to calculate the new surface. Now, again, I don't have an example for this in this case because I'd have to go over to something like Studio Tools and actually produce something, and I don't have that running here. So from here, we have end conditions. Now, you might actually remember this from the Rebuild Curves section. What end conditions is going to do is just rebuild the ends of your surface in U and V, or whichever one you choose, because you can pick a specific direction. We'll go ahead and leave it in U and V together. And when you select this, you have two different ways that you can rebuild your end conditions. You can build them with no multiple knots or with multiple knots. Now, it's good to know that by default, the end CVs of a curve or surface have a multiplicity value of 3, while the inner CVs have a multiplicity of 1. Why is that important to you? Why does that make any difference? Well, it's precisely that aspect of a NURBS surface that means your control vertices sit right on the edge of the surface. If it wasn't for that multiplicity, your NURBS CVs would be floating way out here in space, and I can prove it to you. I can select this surface, switch on no multiple knots with end conditions selected, click Apply. Let's go back to Control Vertices, and now look at my CVs. They're all floating way far away from the surface. Now, as you might imagine, let me delete my history real quick so I can adjust a few CVs. As you might imagine, this will make your NURBS surface very difficult to work with. I mean, imagine if you had a patchwork of 100 different patches and all of your CVs were overlapping other patches like this. It'd be a nightmare. It'd be the hardest thing in the world to try to actually work with. This does make creating tangency a lot easier. Now, you can get an example of that in the Rebuild Curves video, so I'm not going to go into it here because it'd just be a whole lot of snapping. And there are actually a lot of tools for NURBS surfaces for creating tangency that are a lot easier than snapping some 20 to 30 CVs. So in this case, we won't really worry about it. But if for some reason you should find yourself here and you want to get back to the way it was, you can set back to multiple knots like so, apply, and then switch back to control vertices. You'll notice everything is just like it was with your end CVs given some multiplicity so that they can set right back on your surface. And that's really what end conditions is all about, is the ability to change that back and forth. Of course, you still have access to parameter range and direction UV. Now down from here, we have trim convert. And what this is going to do is allow you to take a trimmed surface and make it no longer a trimmed surface. You actually make it into a real live NURBS surface that no longer has a trimmed edge. Now, before you get all excited and think, wow, if I've been using trims, because sometimes when you use trims, you'll have tessellation issues, or it might be difficult to create a surface that molds perfectly into a trim surface. It'd be a lot easier if that trim was a real legitimate NURBS surface. Don't get too excited just yet, because this rebuild type only works in certain situations. And by that, I mean only in situations where a NURBS surface would be possible. Here's what I mean. Let's create a surface, and let's create a curve. I'll scale this up like so. Let's go into the top view. I'll select the surface and the curve. We'll go to Edit NURBS and Project Curve on Surface. I'll kill out the circle, select this surface, and let's trim it out. And I'll just keep the little circle here. Now, by the definition I just gave you, you might immediately think, wow, I could turn this into just a regular NURBS surface. So let's go ahead, let's pick a number of spans for it. We'll say it's got 5 by 5. And we'll set the parameter range to 0 to number of spans. We could keep the number of spans if we wanted to, but we're not going to. And let's go ahead and click Apply, and the surface disappears. It says Result NURBS Plane 1, Rebuild Surface 1, but the thing disappears. Why is that? The reason is that that surface can't actually be a legitimate NURBS surface. So you can't really you can't take this trim and turn it into a legitimate NURBS surface because it wouldn't be four-sided, and all NURBS surfaces have to be four-sided. Now, as another example, let's create another plane. Let's go into a top view, and I'll grab my EP curve tool, and let's click once, click twice. Notice the two points are right across from each other, forming a nice straight line. I'll grab the surface and the curve, and let's do the projection again. I'll come over here to my viewport. We'll kill out that curve, select my surface, go to the trim tool, and we'll trim out the little strip there on the end. So this is a trim surface. It has a trim edge. You can verify it right there. But it's still just a four-sided shape. So why can't this be its own NURBS panel? Well, we can come down here to Trim Convert under our Rebuild settings. We'll make this a 5x5 panel just for this example. Click Apply, and boom. Notice it becomes 5x5. If we right mouse on it, notice the trim edge is gone. This is now just a plain Jane common everyday NURBS surface. So very, very nice feature to get rid of any problems you may be having with a trim surface at the time. You just got to realize that it only works in appropriate situations where the end result will be a legal NURBS surface. Finally, the last rebuild type we have is Bezier. And really all this is going to do is allow you to take your surface and make it into a Bezier surface. And this is where everyone in the room goes, well, Zach, what does it mean to have a Bezier surface? A Bezier surface is a surface broken up into panels wherein each panel is controlled by 16 CVs. At first, it'll look a lot like a NURBS surface, and you may think to yourself, that just looks like a highly tessellated NURBS surface, but it's not. The behavior is very, very different. Let me show you. We'll go ahead and take this plane and make it into a 5x5 Bezier surface and rebuild. Now, check it out. First off, let's go over to Control Vertices. Now, it doesn't look like that actually caught my number of spans, which is okay. Let me jump back over here to my rebuild settings. Start over to Bezier. Everything looks okay at first. Let me start off by rebuilding it uniform into 5x5. Then we'll just convert it over to Bezier, like so. So now it's Bezier. Now look at its CVs. Interesting, no? I'm going to undo that last rebuild. There's a reason. There's a method to the old madness. Look at my number of CVs. This is just a plain Jane common NURBS surface. I'm going to duplicate it. We'll grab the original. This time we'll rebuild this to Bezier. Click Rebuild like so. Let's get all my settings out of the way. And let's go to Display, NURBS Components, Show CVs here. And I'll just select this surface and hit G. And look at the CVs here. Both of these are 5x5 surfaces. Notice one has a lot more CVs than the other. That's because this is a Bezier surface. This is a NURBS surface. Now, if I grab a control vertex here at a point where these isoparms come together at an intersection, I pull this up, look at the kind of reaction I get. Nice and smooth. Now, if I come back over here to this surface and I grab what is essentially the same control vertex, watch this. Not nice and smooth. In fact, pretty jagged and pointy and loses tangency. And that is because each of these panels is, in a sense, calculated separately of the others. In fact, if you grab a control vertex, you can see in your area of effect, you're only affecting inside this area. So I can grab just these 4 CVs, pull them up, and notice it has no change whatsoever over any of the other objects. So if you like working in that particular manner, well, first off, more power to you, and you can do that. You can switch over to Bezier surfaces, and you're good to go. I think I'm just going to stick with my tried and true NURBS surfaces. You can, I would play with Bezier surfaces just for a little bit, just so you can see what they're all about, in case you get asked that on 3D Jeopardy or something. But really, with that, that's everything that the Rebuild Surface Options has to offer. We've talked about all the rebuild types. We've talked about all of the different settings that take place within each of the rebuild types. Of course, you've seen Keep Original many, many times. That's going to give you a node that you can use to adjust all of these settings. So if you want to just do some experimenting based off what you saw in this video, it could be very helpful to you to just go in there, switch on Keep Original, get that rebuild node, and just start tweaking stuff around. Have some fun. And then, of course, you can change your output geometry. So again, the most powerful and probably the most widely used NURBS tool in existence. You're going to be using this a lot. You'll really only be using it with a couple of different settings, but get used to seeing this window, and that is going to wrap things up for this video. Thanks a lot.